In this example, we have a pendulum being used to wreck a building. It's just basically a wrecking ball. The ball weighs 8.0 times 10 to the 2 kgs. It's raised 4 meters vertically, and we want to find the potential energy of the ball when raised. This is just a simple potential energy problem. Looking at what we know, we have the mass of the pendulum, 8.0 times 10 to the 10 squared kgs, which, to use in a calculation, would be 800 kgs with 2 sig figs like that. We know the height of the pendulum, 4.0 meters. And as always, we know G, 9.8 meters per second squared. Potential energy, EG, equals mgh. So 800 times 4.0 times 9.8. Multiplying those together gives us 31,000 joules. The kinetic energy of the ball at the lowest point, well, at this point it now has no potential energy because it's at the lowest point. And we know that since energy is conserved, the kinetic energy at the lowest point will be the same as the total potential energy at the highest point, so 31,000 joules. Speed of the ball on impact, and we're going to assume that the impact happens at the lowest point of the swing so that all of the kinetic energy gets converted. To deal with speed, we need kinetic energy, 1/2 mv squared. EK is 31,000. M is 800. And V we don't know. Multiply 1/2 times 800, we get 400 V squared. Divide both sides by 400, we get 77.5 equal V squared. And taking the square root of both sides, we get that V is 8.8 meters per second. Last question may seem a little bit confusing. We want to know the force exerted by the wall if the ball penetrates 5 centimeters. Well, force is mass times acceleration. We don't have either one of those because this ball is not dropping straight down. We can't use 9.8 meters per second squared. But what we do know is that energy, whether it's potential or kinetic, is the same as work. And that work equals force times distance. The only problem here is that the distance of the penetration I've given you is in centimeters and we need it in meters. So we need to divide that by 100 and we get that the distance is 0.050 meters. Going back to the formula, work, like I said, same as energy, so 31,000 joules of work equals force, which we don't know, times distance, 0.050. Divide both sides by 0.050 and we get that the force of this wall is 620,000 newtons.